In the last chapter, we worked with equations that look like this. 0 equals x squared minus 6x plus 5. And we asked the question, what number or numbers can I plug in for x to make the right side of this equation be equal to 0? In other words, what number for x makes this equation balance? It's as though we were trying to complete an xy table where x was whatever number we plug in, and y was the value of the whole equation here. So the question was, what do I have to plug in for x so that the whole equation would be equal to 0? That's what we spent a lot of time in Chapter 9 doing. Now we're looking at a bigger equation. Y equals x squared minus 6x plus 5. In this case, we're allowed to plug in all kinds of different numbers for x, and we'll just get out a different y depending on what we plug in for x. So for each x that we input, we'll get a particular y as an output. In this case, we could make an xy table, and we could try plugging in different numbers for x and seeing what we get out for y. If I plug in a 0 for x, I'd get out a 5 for y. If I plug in a 1 for x, I'd get out a 0 for y. This is interesting. This connects to what's shown on the left-hand side. This is actually the answer to the question that we asked on the left-hand side of this slide. What number do I have to plug in for x to get out a 0? In our table, we showed that if we plug in a 1 for x, we get out a 0 for y. Interesting. We need some vocabulary so that when we talk about the zeros and roots of a function, we all know what we're talking about. The zeros of a function or functions are the numbers for x that make the whole function be equal to 0. For example, here's a function, f of x, that is x squared plus 4x plus 3. If I ask you what are the zeros of this function, I'm asking what numbers do I plug in for x to make this whole function f be equal to 0. In this case, the zeros of this function are -3 and -1. Watch, if I take f of -3, that is, I plug in a -3 for x everywhere in this equation, I get -3 squared plus 4 times -3 plus 3, and that does in fact equal 0. If I plug in -1 for x in this equation, in other words, if I take f of -1, I also get 0. When a problem asks you for the roots of a quadratic function, that means the same thing as the zeros. It is, what number do I plug in for x to make the whole function be equal to 0? So the roots of the above function are -3 and -1. So how do we connect graphing an equation to the solutions or its roots? Well, here's an equation, y equals x squared minus 6x plus 5. If I graph that, it looks like the blue line here shown. It's a parabola, it opens upward, and we can see where it crosses the x-axis. Those 2 points there, right on the x-axis, if you think about the coordinates of those points, the first point is 1, 0. That means when I plug in a 1 for x, I get a 0 for y. And the second point shown in red is 5, 0. That means when I plug in a 5, I get out a 0 for y as well. The blue line shows all of the xy pairs that are solutions to the equation. The x-intercepts, those are the points that have a coordinate x, 0. Those tell you what do you have to put in for x in order to get out a 0 for y to be 0. So the points where this graph crosses the x-axis are the zeros of this equation. They're the points where if I plug that number in for x, what I get out for y is 0.